So we are starting our unit on vectors. And actually, it's vectors covers 2 units. So this unit is on vectors. Next unit is on polar vectors. I don't know why that's there. All right. So I am going to jump around a little bit in these notes, just because a lot of these example problems are redundant. So I don't want to do all of them today. Before we get started, we should talk about what a vector is. So a vector is similar to a ray that you guys learned in geometry. If you remember way back in geometry, we learned about rays that have an endpoint and go on forever in one direction. A vector is a little bit different though. A vector does have an endpoint, it has a starting point, but it does stop at some point. However, it is still directional. It still has a direction it is going in. So if we look at this little picture right here, our vector is going from P to Q. And we know it's going from P to Q because there's a little arrow here at the end on Q. So what a vector is a quantity that has both magnitude, which magnitude is just a fancy word for size. So it has a size. What's happening? Oh my goodness. Well, so magnitude and direction. A vector is just a quantity that has magnitude, size, and direction. And in this little diagram we have over here, vector P is the initial point, and Q is the terminal point or ending point. And when we write vectors, we use a little small arrow symbol, and you can see, or you can notate vectors using a PQ, or I'm sorry, 2 letters with an arrow over the top, or a lowercase letter with an arrow over the top, or a lowercase letter that is bold. All of these are different ways that you can write vector PQ. This little, we have, I don't know, I'm gonna have to move this over. It's a little better. All right, now there are 4 different things that we're gonna learn today. We're gonna learn about magnitude, component form of a vector, direction angle of a vector, and then also vector components that we can have. And then that's it. That's all we're doing. So magnitude, like I was saying before, is the size of a vector. Size, length, distance. How could we find length of a line? What's one way that we can find length of a line? We did it like a million times in geometry. Also, now with 1. You guys did it a lot. You used it a lot. How can you find length of line? Close, not slope formula. Yeah, the distance formula. Yes, the distance formula, guys. It says it right here. Are you even here? People on the meet. Okay. Oh my. All right. The distance formula is how you can find length of a line. Now, the more tricky part, or what should be the more tricky part, is remember. Oh gosh, no. Is remembering what the distance formula is. So if these are our 2 points, x1, y1, x2, y2, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now notice I have two separate symbols in front of this distance formula. Both of these denote or signify the magnitude of v. You can either write it with absolute value symbols around the v or double absolute value symbols around the v. Both of these mean the magnitude. Both of these mean the magnitude of v. Okay, so let's start. I'm going to do this once because at this point you should know how to plug in values to a formula. And we've done the distance formula in your math careers many, many, many times. So I'm going to do it one time, just in case you're a little bit foggy. We're going to find the magnitude of AB. So I'm going to put absolute value symbols around AB, and it means the magnitude of AB. And I'm going to label these with x1, y1, x2, y2. Normally, if I was doing this on my own, would I label these with x1, y1? No, I would not. I would just do it, but I'm doing this for these values. Okay, the square root of x2, which is -7, minus x1, which is squared, plus y2, which is -2, minus y1, which is -4 squared. And Math Excel, well, sorry, I'm sorry, we're not using Math Excel. Our Google form does want these um, as a decimal, so you don't need to worry about leaving them in radical form. So that means we're lucky, and we can just plug this all into our calculator. Square root of -7 minus 8 squared plus -2 minus -4 squared. And we get 15.1. And you're done. Any questions? How do you find magnitude of a vector given 2 points of a vector? Okay, then we're going to move on. Now I'm going to skip this part. It doesn't really make sense in my head that it comes, so we're going to come back to this. Don't let me forget. We're going to come back to the types of vectors. It makes more sense to me that it comes at the end. All right. So now we're going to think of vectors instead as being in component form. Now, in order to understand component form, we first need to understand what standard position is. If a vector is in standard position, what that means is the initial point, we'll say when the initial point or starting point is on the origin. So as we can see in this little diagram right here, this vector is in standard position because its starting point is on the origin. Standard position. So now that we know where your position is, if a vector is in component form, if a vector v is in standard position with the terminal point AB, so that's our ending point right here, A, then component form of the vector is that ending point AB, but instead of putting parentheses around it, you put these little arrow things. Those arrows tell you that that vector is in standard position. It tells you it's starting on the origin. So anytime you see those arrows, you know it's in component form and you know it starts on the origin. That's why it's in. So you can think component form starts on origin. And the reason why component form in pre-cal we stress it hard is because it makes it easier to find magnitude and also the direction angle we're going to learn about in a second. The reason why it makes magnitude easier, I'm looking at this little picture here, and we know, okay, yeah, we use the distance formula to find the magnitude v. But does anyone else know what else we can use to find the magnitude or length of v in this picture? Maybe I'll jog your brains if I do this. What about right triangle? Or what else do we use on right triangles to find length? Ah, segment. Yes. Look, we know A and B. They give us A and B. What length is this bottom side length? A. Yes, it's X value. So this is A. And what's this side length here? B. So to find the length of V, we use Pythagorean theorem, A squared plus B squared equals V squared. To get the V unsquared, we square root both sides. So to find the magnitude of V, all you have to do when it's in component form, all you have to do is square root A squared plus B squared. The X value of your component form squared plus the Y value of the component form squared. That's a lot less numbers than the distance formula, right? Okay, then also we know A and B. How can we find our theta? What is this A length to theta? It's the blank side. Adjacent side. What is the B length to theta? The what? Yes. When we have the adjacent side and opposite side, what can we use to solve for an angle? Tangent, yes, yes, tangent, TOA, right? Over A, you do TOA or T for tangent. So we know we're using tangent, and tangent is always opposite over adjacent. So that's our B over A. And we're using tangent, but whenever we're solving for an angle, you always use inverse tangent. So you don't need to understand what everything we just said. You don't need to understand any of it. All that you need to remember is this formula. It will be the exact same formula every time to find the direction angle. The direction angle, this angle right here, obviously tells you what direction the vector is going in. So let's try it. We're going to find the magnitude and direction angle for the vectors. Here, in this first example, we have r, and this is in component form because these little arrows equals 7 comma 24. This is our a value, this is our b value. To find the magnitude of r, all we have to do is square root the a term squared plus the b term squared. And I'm going to pull out my calculator. 7 squared plus 24 squared. Then you get the magnitude or the size, the length of our vector is 25 units long. Then the distance angle, we always use the inverse tangent of our b value, which is 24, over our a value, which is 7. Now, back in degree mode. So we need to make sure our calculator is in degree mode. I should probably write that. Degree mode. And we're doing inverse tangent of 24 over 7. And we get 23.7, I'm going to change 73.7 degrees. Whoops. And I'm done. So now I know the size of this vector, and I also know what direction it's going in. So this is actually right now, this vector 724, that's here. So that means this angle right here is 73.7 degrees, and the length is 20. All right, so now we're skipping, we're going to skip all of these examples, and we're going to go to the last part. Last type of problem they could give you. They'll ask you to find, or yes, well, find the component form given the initial points and terminal points of the vector. So as you can see right here, not all vectors are automatically in component form, right? This vector right here is not starting on the origin, but we can find this vector in component form. All that you have to do to place the vector in component form is find the x distance, which you just take the x2 and you subtract the x1, and you also find the y distance. You take the y2 and you subtract the y1. That's all you need to do. Take 2 points of a vector, the initial point and the terminal point, and place those points into component form. We place a vector into component form to more easily find the magnitude and also find the direction angle. We can't find the direction angle unless it's in component form. So let's quickly try it. Let's find the component form for number 7. All you have to do is take, now I'm going to label it one last time, x1, y1, x2, y2. Take these values. X2 is 6, minus x1 is 3. Y2 is 3, minus y1 is 5. And then subtract them. 6 minus 3 is 3. 3 minus 5 is negative 2. So in component form, CD is 3 comma negative 2. Any questions on putting the component form? Okay, so now we're going to do it all together. We are going to take a vector, find its component form, find its magnitude, find its angle. The first thing I have to do is put it in component form. So all we have to do is take x2, which is 4, subtract x1, which is 2, y2 is 1, y1 is negative 9, and then subtract. 4 minus 2 is 2. 1 minus negative 9, that's 1 plus 9, is 10. So in component form, this vector is 210. Knowing this, we can now more easily find the magnitude by doing Pythagorean theorem. This is our a term, this is our b term. We square root a term squared plus the b term squared. So in our calculus, this is 2, the square root of 2 squared plus 10 squared. 10.198. I'm going to round that to 10.2. So our magnitude is 10.2. It's 10.2 units long. And then lastly, we're going to find the direction angle. To find the direction angle, you always use inverse tangent of the b value, which is 10, over the a value, which is 2. So inverse tan of 10 over 2, 78.6. Now, this is where direction angles are a little bit tricky. You always need to think about what quadrant your vector is in component form. So this point is located, this component form endpoint is located at 210. That's about. So because this is quadrant 1, this is our true answer, 78.69 degrees. This angle right here is 78.69 degrees. If our point had instead been in quadrant 2, so pretend it had been over here. When we solved this angle, the answer that it would give us is a negative value, and it actually represents, we're going to say this is, I don't know, negative 20 degrees. It actually would have given us this angle right here. How can we find the true direction angle, this true angle right here? Starting from 0, how can we find that direction angle? What do we know the negative 20 and the angle we're trying to find add up to? What do we know this angle and this angle must, yes, yeah, 180. So how can we find the direction angle in this example? If we know they must add up to 180. Close. If I subtracted 180, it'd be negative 200. Does that sit well? Right. What you can do, in a more simpler sense, is just add 180. If you added 180 to negative 20, you would get 160. This angle here is actually 160 degrees. So we're about to do that in a second. I'll show you what I mean. Erase all this. So let's look right here at number 10. We're going to do it all again. We're going to find a component form. Now I'm going to run through this quickly because I think you understand how to find this. We're going to do negative 4 minus 9, comma, negative 1 minus negative 3. And we end up with negative 15, comma, negative 1 minus negative 3 is negative 1 plus 3, so that's a 2. So in component form, this is negative 13, comma 2. To find the magnitude of AB, we square root the A term squared plus the B term squared. And I already know this answer because I did it before, is 13.15. Now the most important part of this, because this is what I'm going to show you, finding the direction angle. Inverse tangent of the B value of our component form, which is 2, over the A value, which is negative 3. Second tangent of 2 over negative 30. And we get negative 8.75. So we have to think about every single time you're finding a direction angle, you have to think about where is the angle or the vector located. Negative 13.2. Oh, that's all. Is here. The negative 8.75. Every time we have a negative angle, it is an angle going clockwise. So this negative 8.75 is actually this angle going clockwise from the x-axis. That's not the angle we're trying to find. We are trying to find this angle. How can we actually find that angle? Yes, you add 180. You take negative 8.75 and you add 180 to it, and you get 171.25. That is the direction. So I'm going to tell you, whenever you're finding direction angles, if you are in quadrant 1, it stays the same. You're good to go. If you're in if you're in quadrant 2 or 3, you add 180. If you're in quadrant 4, you add 36. Any questions? Does anyone want another example before I move on to the part over? Okay. All right. If nobody needs another example, then let's go back here. This is an easy peasy part. It is just comparing two vectors to each other. There are actually 4 different types of vectors you can have. Parallel vectors, equivalent vectors, opposite vectors, or neither. None, I would say. Parallel vectors are going in the same or opposite direction, but they don't have the same magnitude. So if I'm drawing parallel vectors, A and B, they just have to be parallel to each other, but they don't have to be the same magnitude. So we can say A is parallel to B. Equivalent vectors are the same magnitude and same direction. So they're going in the exact same They're going in the exact same direction and they are the same size. So here, vector M is equal to vector N. Opposite vectors are the same magnitude, but in opposite directions. Whoops. So they're the same size, but going in completely opposite directions. L and K. And opposite vectors are always written as A, and the opposite vector to it is negative A. So here, L is equal to negative K. And then, of course, they could be none of these. They could have no relation to each other. So let's do a couple quick examples. A and E. What do you think those vectors are to each other? A and E. Mm, they are like each other, but they're even more than parallel. They're also going in completely opposite directions. Yes, they're opposite vectors. What about I and F? I and F. They're parallel, but yes, they're equivalent because they're going in the same direction. Equal. I meant to say. What about D and E? These ones are just parallel. What about B and G? Do Monday. B and G. Do they have any relation to each other? No, none. And lastly, C and H. These are again opposite.